Today I want to talk to you about stepper motors. I have this motor, 28 BYJ-48 motor, that I'm going to show you how it works. It has 5 wires here. So let's see how we can control it, how to get it to work. Okay, so this motor runs on a 5-volt DC. It's all given by the data sheet. It has 32 teeth and a step of 1 to 64 gearing. That means it has gear reduction of 1 to 64. And it's a 4-phase step motor. What does 4-phase mean? That means it has 1, 2, 3, 4 electromagnets to control or to run and control the step motor. And the 32 teeth is for the gear. This gear here has 32 teeth. Not literally on this drawing. This is just to explain how the step motor works. But there is 32 teeth. And basically there is a winding here and there is teeth here. When current run through the wire, creates a magnetic field which makes this gear rotate. So what happens is there's different modes we can run the step motor, which we'll talk about them in a second. Here's a simplified version of this. So basically there's 5 wires, we said. So one is blue, yellow. Here are the wires. We got blue, pink, yellow, orange, and red. So the red is always connected to a 5-volt, and the rest will control them through a microcontroller. Okay, so what happens is basically this one electromagnet, which is this part right here, just between the orange and the red, it's one. And then another one between the red and the pink, which is this top one. And then another one here between the yellow and the red. And then another one between the blue and the red. So that's 4-phase. Now, how do we figure out the steps per revolution? We just multiply the number of teeth that we have, multiplied by the gear, and we'll get 2038. How do we control it? How do we run it? Well, 5 volts is applied always to this part here, right? So this is always 1. 1, it means high, digital logic high. So that's 1. Okay? And then what happens is we're going to need to send signal. So if we send 1 through the blue, 1 through the pink, and 1 through the yellow, what happens? So only orange is held at 0. So if this is 1, that means there's 5 volts going through there, and there's 5 volts going through there. So this one right here is not energized. And because the yellow is 1 as well, that means there's 5 volts going in the yellow. That means this whole thing is not energized. Okay? So looking at this one here, the pink is held at 5 volt, and there is a 5 volt over here. That means that side over there is also not energized. Only this one, because this one is held at 0 and this one is high at 1, that means this one is energized. So what's going to happen when this one is energized? So let's say this one is the orange one. So the teeth of this will align with the teeth of this. It'll make it rotate to the right place. And then in this step 2, what's going to happen? We're going to turn off the yellow one. So the yellow would become a 0. The yellow is down here. Okay? So now we have this and this are off. So the teeth will be kind of in the middle. So very small step. Tick. So it's mostly like pointing in that direction now. Okay? And then in the third step, we turn on the orange. So once we turn on the orange, what's going to happen? If we turn on the orange, then this one is off now, right? Because this one is high and this one is high. So if we turn on the orange, only that one is on, which is the yellow one, because it's held at 0. So therefore, these teeth on this side will align with these teeth on this side, and that's step number 3. Okay? In step number 4, we turn off the pink one now. So we go back to the pink, we turn it off. So what happens is we have this one energized and this one energized. So the teeth will align on this side more in the middle between the two. And then once again, we turn off the yellow one, we turn on the yellow one, we keep off the pink one, and then that will make these teeth aligned with this one, and the cycle continues. Now, this mode here is not the only mode you can run the stepper motor with, but there are more modes. So the drive mode, there is a single coil excitation mode. So how does that work? Well, we have 1, 2, 3, 4 electromagnets, and you run one at a time. So you run this one first, and then the teeth will align, and then you run this one, you turn off this one, run this one. Then teeth will align, and you turn off this one, you run this one. And then teeth will align, and then you turn off this one, you turn on this one, teeth will align. So this what happens is, in the full revolution, it can be done in 4 steps. So 4 steps. Because you're not counting for the middle one that we did here, that I showed you the logic for. And then the second one is the full step drive mode. The full step drive mode, basically what you will do is you will turn on these two, then you turn on these two, then you turn on these two, then you turn on these two. And what's going to happen, the teeth will align here, on this direction, in this direction, always in the middle, in this direction, in this direction. Therefore, we have 4 steps to complete a full revolution. Now, in the half-step drive mode, which is what I have here, what I just explained in a little bit ago, this is exactly what it means. It's half-step drive mode, so half a step. So from here to here, then from here to here, then from here to here, then from here to here. So sometimes you would turn both of them at the same time. Sometimes you will turn only one at a time, and then you will alternate. Okay? It has more steps. It'll give you more steps, more precision. Okay? And then there is another one here, which is called the microstepping, which uses sine wave. So what happens is, in the sine wave, for example, if we start from this one, you will energize this one, and say this one is at maximum sine wave, maximum 5 volts, and then as you start stepping this one down, as 5 volts start decreasing, so let's say it becomes 450, whatever, this one will start going up. So this one would be, if this is 450, then this one is sorry, if this one is 4.5, this one is 0.5 volt. So the teeth will start gradually moving over, gradually, and then so on. As this one decreases, this one increases, until this one gets to its maximum voltage, then only this one will be energized, this one will be off. Then as this one starts to decrease in voltage, then this one will start to increase in voltage, and so on. The cycle continues. I will soon show you how to run this motor, and I will explain the circuitry that runs it as well. Stay tuned.